All right, well, sixth grade, here we go with the second part of lesson 8.3. So specifically, we are focusing on lesson 8.3b today. And we have two sets of directions we're going to be looking at. This first one says compare using less than or greater than. So there's no equal in any of these things. One is always greater than the other. So we're going to be dealing with some decimal numbers, some fractions and mixed numbers, comparing them. So, as always, we're going to be looking here at the first number. I've got negative 4 over 5 and 5/8. Now, we've talked about this before. It doesn't really matter what the digits are. In this situation, I don't even have to worry about changing them to a common denominator because one of the numbers is negative and one of them's positive. So there's no question in this situation. It doesn't even matter what the digits are, because one of them's negative and one of them's positive. We know that the positive one, 5 over 8, is going to be greater. Now, we have the same situation here. 2 and 41 hundredths, 3 and 76 hundredths. Don't be confused by the fact that this is a 3 and this is a 2. This is a negative number. Thus, this has to be smaller than 2 and 41 hundredths, which is a positive number. So, in this situation, once again, the positive number has to be bigger. 2 and 41 hundredths. Continuing along with decimals, negative 2 and 75 hundredths, negative 2 and 8 tenths. Well, some of you real quick, if you're in a rush, and Mr. Swack always says, don't be in a rush. You might automatically think that because this is 0.75 and this is 0.8, that this one has to be bigger because 75 is bigger than 8. Don't think that way. Okay? What you do need to think about, and I bring it up anyway because technically in this example, you would get away with that because they are negative numbers. Remember that this negative 2.8 is actually 2.80. So what you might get away if you thought, well, this is bigger and didn't even think about the negatives, but then you might think, well, this is bigger, and I know in negative numbers, the smaller digits are actually bigger. So you might think, well, the 8 is bigger than the 75, and say that this one is bigger. It can get very confusing. Do what it is you know you need to do. Take the time to figure it out. Whenever we want to figure out if decimals are equivalent, we need to make sure there are the same amount of digits after the decimal. Here there are 2 digits after the decimal. Here in negative 2.8 there was just 1, so I added a 0, as I know I can add zeros without changing the value. So this is actually negative 2 and 80 hundredths, negative 2.80. This is negative 2 and 75 hundredths, 2.75. And as I know with negative numbers, the bigger the digit, the smaller the actual number. The idea, remember, of the pieces of candy. You would want less pieces of candy taken because you would end up with more. So in this situation, the bigger number, the one closer to 0, is the one with the smaller digit, 75, being smaller than 80. The 2 is the same, but the 7 in the tenths place is smaller than the 8 in the tenths place there. Meaning this is a smaller digit, but since they're both negative, it actually becomes the bigger number. Where this would actually be a smaller number if they were positive, but since they're negative, this actually becomes the bigger number. All right, so we've got negative 5 and 4/5, negative 5 and 5/6. So, as always, when we compare fractions and mixed numbers, we got to find a common denominator. They're both negative, so we don't get away with automatically knowing like we did in the first one. Here they're both negative, so I've got to think about my common denominator. I have 5 and 6, so I'm going to work with my bigger number, 6. Well, 6 times 1 is 6. 5 doesn't work with 6. 6 times 2 is 12. 5 does not work with 12. 6 times 3 is 18. 5 does not work with 18. 6 times 4 is 24. I can't take 5 times something and get 24. But 6 times 5 is 30. And I can take 5 times 6 and get 30. So I can take my 5 and 4/5 and make that equal to 5 and something over 30. And I can take my 5 and 5/6, and I can make that equivalent to 5 and something over 30. Well, I did 5 times 6 to get 30, so I have to do 4 times 6. That's going to give me 24. So this number is actually negative 5 and 24/30. I did 6 times 5 to get 30, so I have to do 5 times 5 to get 25. This is actually negative 5 and 25 over 30. This one is your negative 5 and 24 over 30. Well, when I think about which one is bigger, I would say, well, this one is bigger because 25 is bigger than 24. But they're both negative. So remember, in negatives, the smaller numbers are actually bigger, which means that this negative 5 and 24 over 30ths, which is equivalent to the negative 5 and 4/5, is actually the bigger number. All right, so let's go into the next part, which is ordering. Okay, ordering the numbers from least to greatest, decimals, fractions, and so forth. So 1 and 5/10, 0, -2, -1 and 4/10, -1 and 56/100. Well, just like what we did when this was whole numbers, we want to think about finding the negatives. So I'm thinking about finding the negatives. Well, that's -2. Here I have a negative, -1 and 4/10. And here I have a negative, -1 and 56/100. Well, this is 2. So I know that 2 and 1 and 1. Now remember, with negative numbers, the negative number is actually the smallest. So I know that the -2 is actually the next smallest one. Now, if I go, well, compare these two negative numbers, that's a 1, that's a 1. So far they're the same. This has a 4 in the tens place. This has a 5 in the tens place. The 5 bigger than the 4, but it's a negative number. This makes this actually the smaller number. Because remember, if I wanted to, I could put a 0 there to compare them, but I don't need to do that. As long as I know in my mind that's what's happening, I don't necessarily need to write it down. And the 5 bigger than the 4, which means that this makes this actually the smaller number when we're dealing with negatives. So the next smallest one would be -1 and 56/100. Then that would obviously then be followed by -1 and 4/10. That leaves me with 1 and 5/10 and 0. Well, clearly once we get to positive numbers, it gets much easier. 0 would be the next one, followed by 1 and 5/10. And that would be my order, putting them in order from least to greatest. All right, so I'm looking at my next one. -3 over 20, -5 over 8, 0, -1, and -3/4. Well, I've got a lot of negatives that I'm dealing with. The only one that's not a negative is a 0. So I can kind of be safe and say, well, it's going to end with 0. That's going to be the last one. But to be able to compare the rest of these, okay, I'm going to need to find a common denominator with these, okay? Now, when I look at the rest of these, I see 3 over 20, okay? I see 5 over 8, I see 3 over 4. All of these have the numerator. 3 is smaller than 20. The numerator 5 is smaller than the denominator 8. Numerator 3 is smaller than the denominator 4. That tells me these are all less than 1, which means the 1 is actually bigger, which means since it's negative, that's actually the smallest number in the set because they took an entire 1 instead of just a fraction of 1. So I know that's going to come first. But let's kind of figure out what's going on here with all these fractions. So I've got to think that what's my common denominator going to be? I've got 4, 8, and 20. Well, 20 is my biggest number. 20 times 1 is 20. And already I know 8's not going to work with 20. So they all have to work. So 8's not going to work with 20, so I don't even have to worry about whether the 4 works with 20. So I go with 20 times 2. Well, 20 times 2 is 40. I know that 8 times 5 is 40. And I know that 4 times 10 is 40. So 40 will work. So I need to come down here. I'm going to have 3 over 20 equals something over 40. I'm going to have 5 over 8 equals something over 40. And I'm going to have 3 over 4 equals something over 40. Well, what did I do to 20 to get 40? I times it by 2. So I'm going to do 3 times 2. 3 times 2 is 6. So negative 6 over 40. What did I do to 8 to get 40? Well, I times it by 5. 8 times 5 is 40. 5 times 5, 25. This is negative 25 over 40. What did I do to 4 to get 40? Well, I multiplied it by 10. 4 times 10 is 40. 3 times 10 is 30. So I've got 6 over 40, 25 over 40, 30 over 40. Remember, they're all negatives though, which means the bigger the number, the smaller it is. So 30 is the biggest number between 25 and 6, so that's the smaller number. So then I would say, well, if we're going to start with, let me go ahead and clear this off. If we've established that negative 1 is the smallest number, and we've established that 0 is going to be the last number, this negative 30 over 40 is the biggest number, thus it's the next smallest, and I always put the original number, negative 3/4. 25 over 40, 25 is a bigger number than 6, but since it's negative, I know this is actually the smaller one. So my next smallest one is negative 5 over 8, which means then I'm followed by my other fraction, negative 3 over 20, and then my greatest number is 0. When it comes to ordering negative numbers, we just have to remember that the bigger the digit, the smaller the number. The idea that negative 8 is actually a smaller number than negative 7, because you think about the cookies. If you baked a dozen cookies and Mr. Swat comes and eats 8 of them, you would have rather had me eat 7 of them, because that leaves you with more left. Okay, I'm not going to eat all your cookies, but you get the idea. Okay, you have more left if I only eat 7 instead of 8. All right, so that's kind of how you have to think about negative numbers. So thus, negative 8 is a smaller number than negative 7. Now, here we got some fractions. Negative 1/2, 1/8, 3/4, negative 1/4. All right, first of all, looking at the negative numbers. Okay, negative 1, negative 1 over 4, negative 1/2. Okay, you know the negative numbers are going to be the smallest ones. Now, when I look at my two fractions, 1 over 4, the numerator smaller, thus I know this is smaller than 1, which means that negative 1 over 4 is bigger than negative 1. Negative 1/2, the 1 is smaller than the 2, which means that this is a smaller number than 1, but since it's negative, it's actually a bigger number, which that means that negative 1 is actually going to be my smallest number. But now I need to compare my other ones, 1 over 2 and 1 over 4. Well, my common denominator, I'm thinking with 2 and 4 is going to be 4. So if I'm going to think about 1 over 2, and that being equivalent to something over 4, well, it's 2 times 2 that gives us 4. So I'm going to do 1 times 2, and so it's going to be negative 2 over 4. 2 is a bigger number than 1, which means when it comes to negatives, this is actually the smaller number. Okay, so that tells me then that my next number is going to be the negative 1/2, followed by the other negative that's left, the negative 1/4, as we're getting closer to 0. Now I've got two numbers here that are positive. I've already used all my negative numbers. I've got two numbers here that are positive, 1 over 8 and 3 over 4. Well, I'm thinking with 4 and 8, the common denominator is going to be 8, which means I've got to figure out 3 over 4 equals something over 8. Well, 4 times 2 is 8, so I need to do 3 times 2. 3 times 2 is 6. That gives me 6 over 8. This is 1 over 8, but now they're positive numbers. So now I can go back to think about numbers the way we normally do. The 1 over 8 is definitely going to be smaller than the 6 over 8, but in my order, I've got to put the original number, which is 3/4. The key, 6th grade, is just remembering when it comes to negative numbers, the larger the digit, the smaller the number. Negative 10 is a smaller number than negative 5. Negative 5 is a smaller number than negative 4, and so forth. All right? We'll talk to you later, 6th grade. Bye.